Okay, this is lesson 10 of unit 1, and we are talking now about negative exponents. So we're going to take a look at our patterns. We see a 10 exponent 3. This gives us 1,000. If I divide this by the base number, so this guy right here, let me just find my color. If I divide by my base, and the base is the number right there, that's your base. So your base is always the large number. If you've got digits, it's always your large number. So if I divide by the base each time I go, that's what's happening. You're dividing by the base. So if I divide by 10 every time, well, what's 10 divided by 10? 1. That's how we end up with this guy becoming a 1. So everything exponent 0 equals 1 on purpose because of this pattern. And I can do it with any number. I could take 2 exponent 3, 2 exponent, 2, 2 exponent 1, 2 exponent 0, 5 exponent 3, 5 exponent 2, and it'll follow the same pattern for all of them. If you divide by the base, now look what happens. I have the digit 1, and if I divide by my base 10, this is what it's showing you. It's dividing by your base. 1 divide by the base. Okay? Now, this 1 exponent is going to be right on the bottom there. It's showing you that exponent, the minute you've flipped it upside down, so the minute you've put it in a fraction, it turns it into its opposite sign. So if it's negative, it's going to flip to be positive on the bottom. Okay? And I'm going to show you about some negative things in a moment here. So this guy's going to be 1 over 10 squared, 1 over 10 cubed. And that tells us how many zeros we have. So that would be 1 over 100 and 1 over 1,000. And you're going to notice the exponents, they've all changed from negative to positive. Negatives turning to positive the minute you've flipped it from its original position. So again, right now, each one of these numbers can be put into a fraction by putting a 1 on the bottom. So I can put a 1 on the bottom of this guy. And then what literally is happening is it's getting reciprocated. Reciprocated means it's flipping upside down. The minute you reciprocate any negative exponent, it'll always turn positive. So for example, if I extend this and I tell you I've got this, let's say I've got 6 to the negative 4 on top of 5 to the negative 3. Each of them are negative. When I flip them and change them positions, they will each turn positive. So that means this whole guy is going to trade places with that whole guy. And the minute I flip them, both exponents will turn positive. So now if I flip it, this is called reciprocate. You're going to see that word. Reciprocate. C-A-T-E. Oh, lovely. It's starting to glitch. The minute you reciprocate, it changes your exponents. So this is going to become 5 cubed on top of 6 exponent 4. Yes? Oh, it froze. Okay. So the minute you reciprocate anything, meaning reciprocate means you're flipping it upside down. You're changing it places. The minute you change it places, it's going to reciprocate and change its sign. So the negative will disappear and then it becomes positive. So now let's take a look at the example with the number 3. Same thing. I'm dividing by the base. Okay, so if I divide by base 3 all the way, I divide this guy by 3, I'm going to get my 1. I divide 1 by 3, it becomes a fraction. That's what a fraction looks like. That's saying 1 divide 3. This guy's saying 1 divide 9. This one's saying 1 divide 27. And all that is 3 squared and 3 cubed. They mean the exact same thing. Identical. So the exponent, the minute you flip it, it's going to turn positive. So now we're talking generic form. So what if your base is a variable? That's what we deal with all the time, is variable as bases. So same thing. Anything exponent 0 gives us a 1. This guy's going to give us 1 over a to the 1, 1 over a squared, and 1 over a cubed. So all we need to do to each one of these that we see in the next question here on B, it says write them with positive exponents. All you're literally going to do is turn them to a fraction by putting a 1 underneath, and then you're going to flip it. That's all you're doing. Put a 1 underneath and then flip. Okay? So now this is going to become 1 over 10 exponent 7. 1 over 3 to the 5th power, and 1 over a exponent n, our generic form, of course. So again, we are able to see negatives as our expanded form. So if I were to write it out as expanded form, so we're using exponent laws to show how this works. So if I'm writing division, so this is saying 5 exponent 4, they've drawn us 5 exponent 4 in expanded form. So this is expanded. And remember, when we took a look at the positive exponents, there was more of them on top and less on the bottom. So that means when we canceled them, there was more on top that we left on top of a fraction. This time, when we get negative exponents, there's going to be less on top and more on the bottom. So over here, we're going to get now 7 5s on the bottom. And we can only wipe out as many as there are on top. So now I will wipe out. And again, 5 divided by 5 is 1. So each one of those are giving us positive 1s. So on top, I end up with a 1 times 1 times 1 times 1. Well, that's giving me my 1. Okay, so when they disappear, they're not just canceling. You have to understand that when something cancels, it doesn't just disappear. It gives you the answer of 1. So the next thing we have left over is we've got 3 5s on the bottom. So that means we're going to have 5 to the positive 3. It's positive 3 because it's on the bottom of a fraction. If it was negative, I could write it as a negative. It would be like this. The answer to this would be 5 exponent negative 3. We never leave our exponents negative. So you're always going to convert them in your final answer to a positive exponent, unless the question specifically says, write the negative exponents, okay, or convert. And if it shows you a positive one, you got to convert to the negative. So this guy here is going to convert to this one, 1 over 5 cubed. And that is 1 over 125 when you evaluate. That's 5 times 5 times 5. So they're just showing us using the quotient law. The quotient law means subtract. So here I would take my 4, subtract my 7 to give me negative 3. And that's what they're showing. So here in generic form, if I want to flip it, I've got a to the positive letter p. I have negative p, so now I've got a to the positive p because I've flipped it upside down. So again, always make it into a fraction. So put it over 1, and then you're going to flip. That's how we get the 1 on top, okay, because you're putting it into a fraction. So we're going to do the same thing to these ones on letter E. We're putting them over 1, and then we're going to flip them upside down. And when we do that, the exponents go positive. So 1 over 2 exponent 1. And remember, the exponent 1 can hide, so I don't need to draw the 1. I'm going to show it to you, but you don't need to draw it. I'm just showing you that it's there. The next one, we're going to have 1 over 3 squared, and then it tells us to evaluate. That means solve the exponent. So that's going to give us 1 over 9. Okay, so we have exponent form, that's exponential form, and then we've got simplified evaluated. Okay, that is solved for us. For exponent negative 3, again, we're going to flip that guy upside down. We're going to get 1 over 4 cubed, and that means 4 times 4 times 4 on the bottom, which gives us 1 over 64. Okay, turn your page, please. So now we're going to see a lovely example here. It says use the division rule to show this. Okay. The division rule is this. If I show 1 dividing by 4 to the negative 3, that's what it's showing. So if I were to divide that, now this guy here is an actual negative exponent. So I would say this is equal to 1 over 1 4 to the positive 3. Okay? So I'm flipping him. Okay, so he's become positive now. So this whole thing has become positive. So this is 1 over 4 to the negative 3. I flip him. He becomes 4 to the positive 3 over 1. Okay, that's when you flip it like that. So if I get 1 times 4 to the 3, this is what this is going to look like now. I've got 1 dividing by 1 over 4 to the 3. Well, how do you do dividing? Do we ever divide with fractions? No, you flip in times. Now, in your calculator, you would draw it out with fractions. So in your calculator, you would do this. You would go 1, divide, and you'd use brackets. 4 to the negative 3 exponent, bracket, enter. Okay, so that's how you would do it. Here, we're doing 1 divided by it. So we are actually going to put 1 times 4 to the 3 over 1. That's what we end up with because we got to flip this guy. And why are we flipping in the end? Because it's a divide situation turning to multiply. When we divide fractions, we flip and times. That's the rule. So divide fractions means flip and times. So flip is your reciprocate. So flip, then multiply. So you have to flip and multiply. That's what it's talking about. So now if I multiply, how do you put any number into a fraction? Over 1. Multiply top to top, bottom to bottom. Well, we're just going to get the answer of 4 exponent 3, which is 64. Okay, that's proving it in long sentences, meaning showing you in the algebraic terms. So showing you by the law, meaning dividing fraction law. We don't divide, we flip in times. We use multiplying rules. So that's all that's showing. Now the negative exponent law, this is what the negative exponent law says in generic forms. Whenever you have a negative exponent, it's equal to the reciprocal of the positive exponent. That's what this is saying. So it's saying if you put this guy over 1, flip it, and you get this. And why do you think they're saying A can't be equal to 0? Well, think about what the digit 0 is. It's always a positive number. 0 is always considered positive. But what kind of number is this? What kind of a digit, what kind of a number is that? It starts with the letter F. It's a fraction. And if it's a fraction, are we allowed to have zeros on the bottom of fractions? No. Your calculator will tell you can't divide by 0. So that's why they're saying the digit A can't be a 0. You're not allowed to have 0 on the bottom of fractions. That's why. Okay? So, not allowed to have 0 on the bottom of a fraction. Oh, it's so glitching already. I-O-N. Okay. So you're not allowed to have the number 0 on the bottom of any fraction. That's not allowed. Okay, so it's the generic laws saying anything exponent, you can exponent negative, flip it, and it's got the positive exponent. Well, what if it's got the positive exponent on the top and the negative on the bottom? You'll flip it. So that's all it's showing is what if you've got a negative on the bottom, you're going to flip it like this so that it goes to the top. So it's saying basically wherever your negative exponent shows up, whether it's on the top or on the bottom, you're just flipping it. That's all it's saying. So this one's here showing, just so you see the difference. This one's showing the negative on the top. This one here is showing the negative on the bottom. And it doesn't matter where it starts. Wherever you flip it, it'll turn positive. So the guy that started on the top was negative, went to the bottom, became positive. The other guy was negative on the bottom. He went to the top to become positive. So I'm going to give you a different example about what that would look like. So take a look at what this could look like, a little bit more challenging. So if I've got a few different numbers, let's say I've got 15 and I've got x, 5, y, negative 3, all on top of 3, w, negative 2, and z, 4. Okay, so let's say that's my situation. So I've got lots of letters, some on top, some on the bottom, and I've got negatives. Okay, devices away, you need to focus for a moment. This is the challenging stuff you're going to see. So locate your negative exponents. That's the first thing you do. Locate the guys that are negative. They're going to trade places. That's all that's going to happen. So now the y's going downstairs. Think of it as a bunk bed. The y's going to the bottom bunk, and the w's going to the top bunk. Okay? And because you've got digits, coefficients in front, you have a 15 and a 3. Those will divide. You're going to simplify those. So if I were to do this question, you also have to simplify just the digits. So this question is going to look like this as a simplified answer. It's going to still be in a fraction because you've got some that are positive on the top and some that are positive on the bottom. The ones that are positive where they start aren't going to move. So the x5 is positive on top, he's not moving, and z4 is positive on the bottom, he's not moving. You're going to divide the 15 and 3, you end up with a 5. Your answers always go to the top. I'm going to actually make one of the numbers negative. Let's just pretend the 3 is a negative on the bottom. Let's just pretend. When you simplify that, your negative will always float to the top. So it's going to take your negative 5, and the negative 5 will float to the top. Now the other letters, the ones we highlighted, they're going to go in opposite positions. One on top, one on the bottom. So W is now going to go on top. Come on, work with me. W, and now he's going to go positive 2. The Y's going to the bottom, and he's going to become positive 3. So these are the two that we switched, and they became positive when we switched their location. So one of them went to the top, one of them went to the bottom. And that's how you will work with it. Some of them that are already positive stay there. Okay, I did not move my Z and I did not move my X because they were already positive where they were. But your final answers, you always want all positive exponents. So those negative ones that we highlighted, we had to deal with those and switch them places. And that's literally all you're doing. So let's take a look at what they're telling us to do in these class examples. So on the first one here, it says express with positive exponents and evaluate. So that means solve it. So this guy would be 5 to the 4 timesing by, 4 to the 5. I got my numbers backwards there. 4 exponent 5. And now I've got to add negative 3. Why am I adding negative 3? Because it's your exponent laws. Exponent laws, if you have the same base, you're adding exponents. So that's going to give me 4 squared, and now I solve it because it says evaluate. That's going to give me 16. Okay, that's going to give me the number 16 as soon as it'll pop up here. Come on. Oh, it's thinking about it. Okay, that always looks like it's not equal. Oh, and it's really running all over the place here. Hang on. It's ending up in different spots that it shouldn't. Okay, I will try again. Equals 4 squared, which equals 16. All right. B, again, because you're multiplying, you're going to add exponents. So I'm going to add 2 and negative 5. That's going to give me a negative 3. So I'm going to get 3 to the negative 3, make it a fraction over 1. That's going to now flip. So now I'm going to get 1 over 3 cubed. And now I solve 3 exponent 3. So that's 3 times 3 times 3. So we're going to get 1 over 27. Okay, the next question. He's negative on the bottom. So I have to flip him. I need to put him on top to become positive. So I'm going to have 2 exponent positive 5. Do I have to show that the fraction is a 1 on the bottom? No, it's not wrong if you show that. But every digit can be put into a fraction by putting over 1. So you don't need to show that. I'm going to show it just so you know it's there. And then you solve 2 exponent 5. I think, yep, it's 32. So your final answer will be 32 for that question. Okay, when we're dividing means subtracting exponents. So now I've got negative 7 subtract negative 5. And you might want to type it in your calculator so you can see where those double negation is, the double negatives. So you've got a negative 7. Those 2 signs in the middle are going to turn to pluses. So you've got a negative 7 adding 5. That's going to give you a negative 2. So you're going to have 6 exponent negative 2. So this becomes 6 exponent negative 2 all over 1. Now you got to flip it to make him positive. So he's going to become 1 over 6 squared. And now we solve that. So that'll be 1 over 36. As soon as it shows up. Yikes. 36. That's a good 36 there. Okay. Last letter, letter E. Well, we have to multiply it in. You always have to remove brackets first. So I've got to multiply that negative 1 to the 3. So negative 1 times a 3 is going to give me a negative 3. So let's just go like this. This guy is going to come over here. So I'm going to get 2 to the negative 3 now all over 1. And now you've got to flip him to make him positive. So this guy's now going to flip upside down. And he's going to become 1 over 2 exponent 3. And 2 cubed becomes 8. So I get 1 over 8. Any questions with those so far? You're still using your exponent laws. So if you're dividing, subtract those exponents and then deal if it's negative. Okay? Always solve what you're doing first. Changing the negatives to positives is your last step. Okay? Your very last step. You don't do it at the beginning. All right, let's take a look at the next ones. Let's see if these are true or false. Let's see if they subtracted their exponents proper. Why am I subtracting? Because it's dividing. A dividing situation says subtract. So if I've got 3 subtract negative 1, double negation in the middle, turn to positives. So 3 plus 1 is going to give us our 8 to the 4. So yes, they did it correctly. So this guy is true. All right. Whoa. What did they do on B? What's going on B? Why did I make that big whoa statement? Does B look crazy or is B okay? B's a little crazy. What's wrong with B?
Dividing 2 different numbers.
That's right. They're 2 different bases. If they're 2 different bases, you can't do the rules. You can't use them. So that means that question alone, you'd have to simplify each. So this guy's false. You would have to simplify each number and then literally divide it. So you would solve 8 to the 3 and you would divide by 4 to the negative 1. And you'd literally have to do it. You'd solve, then divide. Okay, so that's a BEDMAS question. If you have different bases, the rules do not apply. You have to have identical bases. So always that's what you're checking. On C, are they identical bases? Do I have the same letter? Yes. Let's see if they did it correctly. So it starts out looking like that. Everything has a 1 on the bottom. They flipped it. Did they flip it correctly? Yes, this guy is true. Okay, they flipped that one correctly. What about the next one? Did they flip him correctly? Let's look at our base. Is our base 9 and A, or is our base just 9, or is our base just A? Is your base 9 and A?
I think it's just A.
It's just A. Your base is only what's attached to the exponent. The 9 is your coefficient. So the only thing that's attached to the exponent is the part that's going to flip downstairs. The 9 has a positive 1 exponent on him. He's not going anywhere. He's staying upstairs. So if I put this over 1, which every number gets, over 1, only the A to the 3 is going to go to the bottom, not the 9. So this guy is false. What he should look like is 9 over A3. That's what he should look like, because 9 has a hidden positive 1 on him. And positive exponents stay where they are, whether they start on top or start on the bottom. If they're positive, they stay and leave where they're at. Okay, class example 3 on this page. Here we go. It says, write them in positive exponents. Well, again, we have to do what the rule says. Here, if I'm multiplying, we're going to add exponents. So I'm adding them. I'm going to get A negative 7 over 1. Never leave it negative. It says we want positive exponent answers. So that means I got to flip this guy upside down. So my final answer will be 1 over A positive 7. Always circle or box your final answers, especially on quizzes, so I don't have to search for them. Okay, on the next one. Is your base the digits or the variable? The variable. The digits are your coefficients. So since you're dividing, you will divide the coefficients. So these guys actually do divide. So they're going to give you a 3. Now you're going to subtract exponents. So you're going to get 2 subtract 7 for your exponents. That's going to give you a negative 5. So you're going to end up with x negative 5. And that's all over 1. Now this is that situation like with this 9. Is the 3 part of the negative that has to flip? No, the 3 is not part of it that flips. So this is now going to look like 3 on top of x5. Okay, only the negative part is going to flip to the bottom. That's all. This guy has a hidden 1 in front of him. So you've actually got a coefficient of a fraction 1 over 2. That's your actual coefficient. So I'm going to subtract my y's. I get 6. Come on. 6 subtract negative 5. Double negation in the middle. So that means they turn positive. So that's going to give you 11. So you're going to get 1, hidden 1 on top. Come on now. 1 y. Whenever you solve your variables, they go on top to start with. 1y11 over 2. That should be a y11. Now, another way I could write that is like this. I could write the 1 over 2 as a fraction. So I could go 1/2. Whoa, holy glitch. Hang on. So you write your fraction separate, 1 over 2, and then you'd put your y11 beside it. Okay, so that's the other way you can write it. And again, fractions should be in brackets if you've kept it. Now, the y11, if it was written like that and they said, who does the y11 belong to, the 1 or the 2? Well, he would sit with the 1 on top, okay? All right, look at D. Look at D. How is D different from the one I just did with this guy? How is D different than this guy right here being the negative? The 2 here is not part of my base. Is my negative 2 part of the base there? Yes, it gets the negative. It's in the bracket. So this right now is all over 1. So you're going to flip it. And this whole thing's going to now become 1 over negative 2x to the positive 3. And then it wants us to solve that. So the only thing we can solve is putting the exponent in the brackets. So right now I've got a hidden 1 on my 2 and a hidden 1 on my x. To remove the bracket, that 3 has to multiply to both of them. So this is going to look like 1 over negative 2 cubed x cubed. Now, we all know that in a final answer, your negative will float to the top. So the negative is going to go to the top number. So this is going to look like negative 1 over 8x cubed. Negative 1 over 8x cubed. Now, you could have the negative sign on the bottom if you want, or in the middle beside the fraction bar, but it's usually at the top number, just so you know. All right, the next question. You've got digits that you can divide, and then you got to subtract. But do you have identical letters? No, the letters are different. So this is that case that I showed you where if the letters are different, but they're both negative, they're just going to swap places. One's going to the top bunk, one's going to the bottom. So that means the B is going upstairs and the A is going downstairs. That's all it means. They're literally switching places. But you will divide the 8 and 4. So the 8 and the 4 is going to divide, and it's going to give you a 2. Your B is going to sit on top, and on the bottom, you're going to have a positive 5. And that's as far as that one goes. You can't do anything else to that question. Okay, the next one, we got to put the negative in first. Well, actually, we really don't, because what are we noticing? Are the letters the same? I have a P on top and a Q on the bottom. Are the letters the same? No, so I'm not going to be able to add them or subtract them anyway. All I've got to do is deal with the negative. Well, the negative applies to the 5 and the P. They're both going to get that negative. So what this is going to look like to begin with is 5 negative 2, P negative 2, all on top of 5, Q 4. Now, the negative ones are going to have to flip. They're going to go downstairs and join all those other things. But what's sitting beside all of it? Whenever you remove everything from a top of a fraction, this is saying that this is between, crummy. Hang on. Let's get rid of all that. It's like saying they've got brackets with a 1 out front. So whenever you take everything away from the top of a fraction or bottom of a fraction, you're going to have a hidden 1 out front. So that 1's going to stay there. So you're going to end up with this. 1 on top of your 5 squared on the bottom, P squared on the bottom, 5 to the 1 on the bottom, Q to the 4 on the bottom. Now, they're all sitting side by side, so they all mean timesing. But do you notice I've got a 5 squared and a 5 to the 1? Am I able to combine those? Yeah, same base, right? Same base multiplying means I can add their exponents. So that's going to give me 5 exponent 3. So these two right here are going to give me 5 exponent 3, which I get to solve because it's a digit. So my final answer for letter F is going to be 1 on top of 125, because that's what this guy gives me, 125. And then I've got my P's and my Q's there. P squared, Q4. Okay, P squared, Q4. Any questions so far? I know it's a lot, and you literally just need time to practice this stuff. Okay, flip your page. We've got about 4 examples to go through, and we're done. And then you've got the rest of the time, and I will give you time tomorrow. You guys need a full work period. I'm going to give you guys a full work period tomorrow, okay? So tomorrow we're not doing a lesson. Tomorrow is a full work period, and that means the people that have got quizzes or things that they want to redo or they want to do, they can do that tomorrow as well, okay? Because you need time to practice this stuff. Okay, here we go. These guys here, and we got a whole bunch dividing by a whole bunch of things. So the first thing we're going to do is we are going to, if we're dividing, we got to simplify this part first because it's in a fraction. We have to simplify him first because we can't have a number of different fractions all at once. So we are going to subtract exponents. So this is going to give me x3. My y's are going to subtract. 3 subtract -3 for my y's is going to give me y6. Okay, so x3, y6, and now my z's. I've got z -1 subtract 2. That's what I've got on my z's. So -1 subtract 2 gives me -3. So I got z -3. All right, it's easier to write a divide situation as a fraction. So I have simplified the whole guy on the right-hand side. He's going to have the number 15 sitting in front of all that. So now I'm going to rewrite it as a fraction. So this guy's going to be the top, and this guy's going to be my bottom. And then I got to simplify. So on top, I've got 5, x3, y -8, z -2, on top of 15, x3, y6, z -3. That's my situation I'm dealing with. So now I look at my digits, the coefficients out front, 5 and 15. They won't divide evenly. They're going to give me a fraction. It's going to give me 0.3 repeating. So that means I'm in a math bracket. Well, as we know, to reduce, they both divide by 5. So I'm going to get 1 over 3. So this is going to give me a 1 over 3. Okay, I've dealt with my digits. Now we're dealing with the x's, y's, and z's. What do we notice about x? It cancels, yep. So x is going to disappear because 3 subtract 3 is going to disappear. And now on my y, so now on y, I've got -8 subtract 6. What's that going to give me? -14. Now, whenever we solve a variable, he automatically goes to the top of the fraction no matter what. So my y -14 starts on top after I've simplified. The z's. Now on my z, I'm going to have -2 subtract -3. Well, I've got double negation again. So these guys go positive. So -2 plus 3 gives me a +1. So again, you solve your variables. He sits on top to start with. He's a +1. He's going to stay there. The only one that's going to change positions is the y is going to go sit with the 3 on the bottom. So your final answer is going to look like 1 z to the 1 on top of 3y to the 14. And that's as far as you can go. All right, we're going to take a look at the next one, and we have to explain why those are not equivalent. What is wrong with what looks like there? Yep, Jace?
2 is the coefficient, so it goes to the top.
Exactly. 2 is the coefficient. He should be on top. He's not part of the base, okay? If he had a negative exponent, you bet he'd go to the bottom as well, but he has a hidden +1. So the final answer should look like 2 over p cubed. So that 2 should be on top, not on the bottom with the P. Okay, last example on the bottom. What if it's fractions? What if you've got fractions? Holy cow. What if you've got a fraction? Well, fractions, first of all, get brackets. The first thing we need to know about fractional bases is brackets always. Okay, and the only way to solve a bracket is to multiply the outside exponent inside. So that -4, we flip him because it's a fraction on top of 1. I flip him, and my 4 is now going to become positive. So that means I've got 1 over 2 to the 4th, which is 16, over 3 to the 4th, which is 81. So 16 over 81 becomes your bottom fraction. And again, it is a fraction, so it's going to stay in brackets. It's not going to remove brackets because fractions just stay in brackets. So now that means you're going 1 times, flip it. 1 times. So this is saying this. 1 divided by 16 over 81. We don't divide fractions. We change this to a multiply sign. When we change it to a multiply sign, we flip the fraction. So that's why the 81 is going to go on top and the 16 is going to go on the bottom. And that'll be our final answer because 1 times that is that. So you end up with 81 over 16. Now, the short way to do it, I'm going to show you the short way to do it with the next question. So it says evaluate 3 to the 4, 2 to the 4. Well, 3 to the 4, 2 to the 4 is 81 over 16. So what are we noticing? The negative exponent with opposite up and down, they are equal. This is a true statement. Okay, that is a true statement. So I'm just going to show you this one down here, what this means. So 5 over 2 to the -3. That's the same thing as me saying 2 cubed over 5 cubed. All I've done is I've flipped it and put the 3 on both numbers. That's all you do. You flip it and put the 3 on both numbers, and then you'd solve it. So that's going to give me 8 over 125. Okay, so that's all you're going to do. The minute you see negative with a fraction, flip the whole fraction inside. The minute you flip the whole fraction inside, the outside exponent is going to convert. So this guy here, he flipped inside, his outside exponent went positive. Okay, so anytime you've got that. So here's one last example. If I've got 7 over 8 to the -2, that is the same as me saying flip the inside. Okay, 8 over 7, flip the inside, make the outside exponent positive. That's all it is. So you flip the inside guy, which again, we know that fancy word means reciprocate. Okay, and this ends lesson 10.